Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Hi, everyone, and welcome to the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Each episode, we share the latest discoveries, observing techniques, and stories from the people who explore our moon, planets, comets, and beyond. Whether you're looking through a backyard telescope or leading professional research, we are all united under one sky. I'm Tim Robertson, your host, and thank you for being there. Now, if you usually listen to the podcast in your car or on your phone, did you know that you can now watch it too? That's right. The Observer's Notebook is now available in video right here on the ALPO YouTube channel. And here's an interesting fact. Over 70% of the people watching or listening are not subscribed. So take a quick second, hit that subscribe button, and ring the bell so you never miss another episode. It's free, and it really helps grow this channel. This show is made possible from support of you, our listeners. If you'd like to help keeping the Observer's Notebook going, check out our Patreon page at patreon.com/Observer's Notebook. For just $1 a month, you're supporting the show. For $5, you get early access to the new episodes. For $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you'll be listed as a producer on this podcast. And of course, to find out more, visit www.alpo-astronomy.org, where you can join the organization for as little as $22 a year. And now get started with episode 236. And we're talking to one of the greatest astrophotographies of this time. Enjoy. All right, I'd like to welcome everybody back to this edition of the Observer's Notebook podcast, the official podcast of the Association of Lunar and Planetary Observers. I'm your host, Tim Robertson. And tonight we're honored to welcome one of the most respected planetary imagers in the whole world, Christopher Go. Christopher has been an amateur astronomer since 1986 and an astrophotographer since 1990. He's observing from the island of Cebu in the Philippines. His work has helped bridge the gap between amateur observation and professional planetary science. In 2006, he observed that Jupiter's oval BA had turned red, the feature that was known as Great Red Spot Junior. And that discovery led to professional follow-up observations with major facilities such as the Hubble Space Telescope and Keck. Christopher, welcome on board to the Observer's Notebook podcast.
It's great to be here, and also I'm happy to be, helping out with ALPO because, I've been connected with ALPO since, during that time I started, imaging planets, which was over 25 years ago. So it's been quite some time.
Goes by fast.
Yeah, it is.
Yeah. So take us back to the very beginning. What first drew you into astronomy?
Well, I was still in high school during that time, and it was the time of the Halley craze, 1985, 86.
Yeah.
What really changed everything was when I went to a local supermarket, and lo and behold, there was an astronomy magazine. So that's how things got started. Because normally, if you go through astronomy books, especially here in the Philippines, the library we have. Most of the books on astronomy we have are, shall we say, pre-war, pre-World War II. So they were quite old, and being able to get to know that, especially during that time, that there's a magazine dedicated to astronomy. And after that, I started subscribing to, astronomy, Scan Telescope. So these magazines have a big impact on me developing, my knowledge in astronomy, mostly deciding on which telescope to buy, and all these things. And these magazines have been very important more than anything else, especially during a time where there were no internet. Right. Everything was done through snail mail. So it was a big impact for me.
Yeah, well, it's not only the Philippines that they were antiquated with their books. My high school textbook in astronomy told me that Saturn had 9 moons. So it wasn't very accurate at that time either. So what
Yeah.
was the sky like growing up in Cebu?
Well, the sky here was great when I was growing up, unlike now where things are quite horrible. Uh, you know, Cebu grew exponentially since the time I started astronomy. Even when I transferred, I used to live in the middle of the city, and even during that time, I can see, Edaka with my naked eye.
Mm,
Right now, I can't do it anymore. Even
right.
Orion Nebula, it's just too bright. The city just grew. Yeah, so it was very nice before, but now not anymore. Well, the city, the Metro Cebu grew about almost 10 to 20 times
Ugh,
in area. So yeah, it has been quite a big difference.
my goodness. Now you mentioned trying to decide what your first telescope was. What was that first telescope?
My first telescope was a Meade 2080 LX5.
That's a good
So
first telescope.
it was a good, well, technically my first telescope was a pair of binoculars, a 10
Okay.
by 40, which my mom bought for me in the local department store. But of course, that was just the start of it, and
Mhm.
it was quite nice because for me, starting with the binoculars, I was able to see probably 70% of the mazy objects with that binocular. So I think this is something that's probably lost in
Mhm.
this day and age of go-to and everything.
I hear you.
I remember before when we started astronomy, there was no such thing. Well, there was this CompuStar, but who could afford that thing?
That's
And it was quite difficult to use. And yeah, even astrophotography. I actually started astrophotography in the around 88, 89,
okay.
when I basically swiped my mom's camera, but it was just with a tripod and do what a lot of people are doing now, landscape, with the Milky Way and these things without any guiding.
Hmm.
With film, yeah, it's quite a difference. So when I started getting the meat, it was quite difficult to get it here because of number one, here in the Philippines, it's a bit tough to ship here, plus all the taxes. So
Uh,
that's where I started. And the thing is, when I got the LX5, I found out that it wasn't ideal for my location because it's a fork mount, and when you polar line it, it's a pain because
uh,
I'm about 10 degrees north of the equator. So
oof.
it's kind of awkward. Yeah, it's basically, yeah, the when it's polar aligned, the fork itself is like lying down.
You're right. Yeah. That's
Yeah, so
that doesn't sound like much fun. So
yeah, so
your main astronomical interest became planetary imaging, especially Jupiter and Saturn. What attracted you to the planets instead of deep sky?
well, the light conditions here,
Oh, okay, that makes
light
sense.
pollution. You know, it's just like when you're in Los Angeles. It's difficult to look at stars there, and the same thing happened here. And also, yeah, that was basically the thing. And the reason why I got attracted to the planets, actually, I started imaging planets with film. I think in the early 90s,
Okay.
or yeah, early 90s. When I got my telescope, the first image I got was an image of Jupiter. But of course, remember that time you have to do eyepiece projection,
Mm-hmm.
all these things. Yeah, so I started with that, and when the CCD revolution came, I started basically in the early 2000s, when I started with a webcam, the Philips UCam,
Okay.
and that's when I discovered that my conditions here are actually pretty good for planetary imaging, especially here when well, we have three things that is going for us. Number one, we're very close to the equator, so even at worst, the planets are a bit high
That's
compared
true.
to in our location. And the second, which is also very important, is we don't have the jet stream here.
Hmm.
So
Yeah, stable air.
Yeah, very stable air. And the third is that I get laminar flow. It's a small island. I live basically 2 miles from the sea, on a hill, but 2 miles from the sea. So one thing nice is that being on the hill, the humidity here is not as bad as in the sea level. And the thing is, when I get laminar flow, the seeing is just like crazy. I mean, everything is just so stable. Like sometimes you wonder that, probably your computer crashed because the image of the planet just froze.
Wow, that would be. I can't experience that. I have no idea what you're talking about there.
Well, yeah, actually, I've tried imaging in the observatory they have in Torrance in Celestron, and
Yeah,
yeah, it was horrible.
yeah. I'm in Southern California, so I can completely relate to that right now. Yeah. So, what was the first image that you took that you thought, okay, I can get serious with this now?
Well, it was Jupiter. When I started posting it, at first everybody couldn't believe my images, especially with the resolution I was getting. I started with C8. Actually, what I did was that I sold off my LX5 and basically upgraded to a Lossmandy mount,
Oh,
GM8. Then yeah, got a C8, and it was during that time that I started buying. I think in the mid '80s, I got astrophysics AP130, which I thought would be an ideal
hmm.
planetary telescope. I got it. During the time when nobody was buying astrophysics, I got it 1 month after I ordered it. I think this is
Oh
unheard
my
of now.
goodness. I think I still have one on order from 1985.
Yeah, yeah, I know, I understand. And it was also during that time that I got it was an AP900 QMD. So basically, once the CCD revolution, the 2U came, then
Hmm.
I started to image the planets in the early 90s. And from there, I started upgrading to, a C11, then to a C14. And also my mount, I sold off my QMD and got the GTO AP900, which I've been using since 2003.
Oh
And
my.
it's been quite reliable for me. It's been out there and basically every day of the year except when there's a typhoon. So, yeah, it's been quite a reliable mount that I've been using. And yeah, as the telescope get bigger, I get higher and higher resolution.
Hmm. All right, let's go back in time. Let's talk about February 2006. You notice that the oval BA had turned red, and what exactly did you see, and when did you realize it was something significant?
Well, I've been imaging Jupiter since I think 2002, 2003. Since that time, I mean, I've been familiar with what Jupiter looks like. I've been imaging Jupiter whenever there's a clear, when the sky's clear,
Hmm.
whether it's early in the morning at 4 a.m., up to early evening. Right now, it's a bit difficult as I'm a lot older right now, so it's a bit difficult to do that. But I still keep up. So it's quite funny because during that time, and I think it's February 25 locally or 24 in Universal Time, I actually overslept and I basically woke up at around almost 5 a.m., which is a few minutes before sunrise. But I don't know why. I just went ahead and took an image with a. I think during that time it was with a EIS 21. I forgot the small chip.
Okay.
The DMK 21 something M. So I started with that, and when I took some image, I noticed that the oval BA turned red, and from coursing through images from ALPO Japan, we found out that yeah, it probably started around during the tail end of the previous season. So it was quite surprising, and so I just posted it on ALPO during that time, and and that's I got 5 minutes of fame from that.
Oh, you've gotten a lot more than 5 minutes of fame from that.
Yeah.
So how quickly do the professionals respond and get involved?
Actually, I think 1 or 2 weeks. I don't actually after the discovery, Tony Phillips, I think
Mm-hmm.
you know him from spaceweather.com, just emailed me and he wrote an article on Science at NASA about that. Then I think by the end of February, I got an email from Imke de Pater from UC Berkeley asking me to join her team that will be using the Hubble Space Telescope to image Jupiter. So that was the start of my Hubble Space Telescope adventure. So from there, it's like every year we had an opportunity to image with Hubble Space Telescope. It was a group with Imke de Pater, Dr. Phil Marcus, and right now also Mike Wong. Mike Wong, I've been working with him. He was our, shall we say, quote unquote, mission specialist because he was the one who was connected to the Space Telescope and Science Institute. I've done a lot of work with him. Right now, he also is part of OPAL with Amy Simon, the Outer Planet Atmospheres Legacy Group, and and also Sheila Isa Davis. So this group, we were able to basically study the evolution of oval BA and made some guesses on why it turned red. And it was also during that time with Imke de Pater, we were able to use the Keck telescope. And I had a sideline joint venture with the Gemini Observatory. I wonder if you know this guy, Chad Trujillo. Chad Trujillo, he's the partner of Mike Brown.
Okay.
They co-discovered the one that killed Pluto.
So
I became good friends with Chad Trujillo through these contacts. And lastly, one of the first or the second spacecraft image of the red oval BA was done by none other than the New Horizons spacecraft. So I got to get close to Alan Stern. So I've been close friends with Alan Stern, and in fact, a few years later, a group from New Horizons actually came to Cebu and here in my house to image a transit of basically an occultation of a star by Pluto. To measure the atmosphere before New Horizons arrived in Pluto. I think it was around 2012. So it's been quite an adventure to be in contact and connected to a lot of professional astronomers now.
Yeah. So how has this moment or that moment in your life changed your thought about being an amateur astronomer?
Well, first of all, even before that, I've been imaging planets and been in contact with some professionals. But it was also during this time that I started a group called, I wonder if you've heard of it, the HST Jupiter Group. So this is it's a close group of basically some of the most prolific imagers, planetary imagers in the world, and many of the top planetary astronomers. So this group has been basically where, if anything happens in Jupiter or Saturn, it's usually reported in this group. So I started this in, actually it's 20th anniversary. I think it was April 24, 2006. So this year is our 20th year. Oh no, it's March 24, 2026. So and it's been quite an adventure. This group, a lot of historic discoveries in the different planets, not just Jupiter, but also Mars, Saturn, and even Uranus, because a lot of professionals on our group, like Mike Wong, Glenn Orton, Amy Simon, Ricardo Huesco, Agustin Sanchez La Vega. I think you know these people.
Yes, I do.
They're the hosts who in Lee Fletcher. So these are part of the group, and basically, yeah, we had a lot of joint work with Cassini, Juno right now, and of course the two new spacecraft that are going to Jupiter, JUICE and Europa Clipper.
Right.
So we are very involved with this, and yeah, and it's been fun. I mean, right now I would say, amateurs basically carry the load on the planetary observations right now because having used professional telescopes and the Hubble Space Telescope, you understand that in the pecking order of things, planetary astronomy is in the lowest level.
Mm-hmm. That's true.
And getting time, even with Hubble, for every 5,000 proposals, only, let's say, I think 150 or less than 200 is accepted every year.
Mm-hmm.
And we're just lucky because of OPAL, we have a guaranteed observing time every year. So at least we get to image the outer planets from Jupiter, Saturn, Uranus, and Neptune every year. So we get some data there.
Get some time.
And get some Hubble time. And we even have Spitzer time. So these astronomy friends of mine, they would just post on HST Jupiter, oh, we have some observing time and we need your images for context. So, we get members all over the world, around the world, from Europe, Africa, Asia, South America, Australia, all over the world. We have worldwide coverage. So it's easy to basically do the support for them. And they really appreciate that. And I think you've noticed that a lot of amateur astronomers have become co-authors of different papers published by professional astronomers. So yeah, it's for me, this is the most important thing, that amateurs basically are helping out professionals, and the professionals really appreciate this. I've seen some parts of astronomy where professionals seem to find amateurs to be bothersome or these things, but in planetary astronomy that's not the case.
That's true.
In fact, we have JUPOS that basically provides data for professionals. And I think with ALPO also, we have and BAA and ALPO Japan. I think there's this strong connection between what we're doing and real science.
That's very true. Yeah. Now Jupiter's not a static object. It's living. It's changing.
Yeah,
every night it looks different. So you post observations daily of what you see. What should observers be looking for today on Jupiter?
Well, actually, it's not really about what you're looking for, but just take an image. I mean, because each image is unique, and the guys in JUPOS are very need these images. In my case, I can't really image every day because, like, example, right now for the past few days we've been having cloudy weather. So others pick up my Slack. So we can still get data, but there's one thing that you can do anything, but please don't use AI, because I've seen some people that have been posting images, doping Hubble data, and of course you can see when an image is from Hubble, because number one, Hubble images it doesn't use RGB. I process Hubble image for the professionals for OPAL. In fact, if you notice, one of the more famous image of Jupiter, I think it was about the shrinking GRS, and I think this image of Jupiter has been used basically as a standard image of Jupiter. I was the one who processed that data for them, and it became the standard on how this thing is processed. But the thing is, it's not done using an RGB filter. It's basically a narrow band. I would say it's an R, B, and V. V as in violet, around 300 nanometers. So 390 nanometers. So you can see that the color is a bit off. That you can see some amateur image that pick up that data. and you can really say, "Oh, this thing is dope." I mean, this is one thing. I've been telling people, even if my data doesn't look good, I just post it because what you need is image fidelity. I've seen people using AI, ChatGPT to basically quote unquote enhance their image. I mean, that's horrible. I mean, you're polluting the data, and it frustrates people in Jupos when they see these things, and it's as if that we don't know, because most of these features, they change, and with a lot of imagers, we know immediately when that thing is dope.
Right.
So this is something that people have to bear in mind. Well, if they want to do some work of art, then they should, of course, indicate that it's a work of art. But usually, we're more concerned with the fidelity of the data.
Yep.
And to give an example, remember a few years ago there was this. Have you heard of the Dragon Storm in Saturn? It was a huge,
yes.
I would say, an equinox storm, which appeared in Saturn, and it started with. I think during that time we discovered that it started with an electromagnetic anomaly that appears with in Cassini, and it was quite interesting that the first person to image it was an amateur astronomer, which was part of my group in Iran. And although his image wasn't perfect, but he was able to capture the start of that storm, which for professional astronomers, that data was so important. Unenhanced, no AI trash or anything. But even with that, not perfect data, what we need is the position of that storm, and that thing really helped a lot. So it's not a matter of having the most beautiful image. In fact, in my case, when I do my imaging, that's not my goal. I mean, the only reason why my images are good is because of the seeing. And for me, when the seeing is good, then I don't have to process a lot. I'm not there to get every ounce of detail on my image. I just, in fact, the thing is, I have a day job, unlike some, I know some amateur astronomers that are retired and do this full time. Then they can do whatever they want. And of course, most of my friends there, they of course they do everything legit, but they're able, they have time to do that. I don't have that time. I have to work. I have a family, and my wife's gonna get upset if I spend too much time with astronomy. So I try to limit my time, make things as efficient as possible, make things as fast, and just publish it.
Yeah,
make sure that all the features are as accurate as possible.
Yeah, the subject of AI and astrophotography is such a hot topic right now. I know Damian Peach has gone off on his own thing with it as well, and it is a topic for a lot of podcasts, I think, to really discuss, because we have to get a handle on it. We do. We really do.
Actually, for me, there are enough tools available right now that you really don't need AI. I mean, why do you need AI? I mean, there is enough tools. And quite frankly, if your data is bad, if no matter how much processing you're going to do, you're not going to get anything out of it. So enhancing it would pollute the data, and this is something people have to understand. In my case, if things are so bad, I don't even bother to image anymore because I don't think there's enough, and there's enough imagers in the world that can basically image that area and contribute. My concern is, there's an image of this region every day, and here in my region, there are people in Japan, Hong Kong, Taiwan, China, in Southeast Asia, Malaysia, and Australia that are imaging. So there are a lot of backup people doing it, and it doesn't have to be me to be doing it always. And that's why I also try to help out and sharing my technique to other imagers so that everybody could get good data. And
Yeah.
for me, that's more important than anything.
I hear you.
Being able to understand what's going on with the planets, especially with JUPOs, then with all their measurements, it's beautiful to see, the motions of these small spots, and it'll help us understand more about the atmosphere of Jupiter. This is for me the bottom line. Of course, there are some people who want, to make beautiful images for Facebook or everything.
Mm-hmm.
Well, it's a free world. You can, of course, do it, but of course, you have to say that
it's modified.
It's a work of art.
Right.
So you don't have to say that this is a real image of Jupiter, or you have to indicate that, oh, I doped the image of the Hubble image. In fact, there was a time when there was a guy who doped my image and Damian's image and made it their own.
Yeah, I think that's what ticked off Damian the most. I think that's what it was.
Yeah.
So going back to Jupiter today,
Hmm.
are there features on Jupiter that are especially interesting to you right now? Some activity?
There's no, this year has been quite, quiet for Jupiter, except for the Great Red Spot right now and the immediate vicinity, because there are two features there. John Rogers is about to name one of the feature, the STB Phantom. So these are dark cyclonic features that are slowly getting close to the Great Red Spot and interacting with it. And you'll notice that the area in the south of the Great Red Spot is getting exciting. A lot of red leakage is coming out.
Okay.
Probably some color material, the red material of Jupiter is spilling out because of the interaction with these cyclonic spots. So these are some of the things that are happening right now. But one of the things that I've been pushing for people, and because this is something that can happen anytime, are the impacts on Jupiter. So since Anthony and I discovered the first impact on January 3, 2010, there has been over a dozen impacts. And there's a software called Detect by Marc Decoy that basically, it's also timing that we take videos of Jupiter. So we just feed our raw data with the software, and basically it searches for if there's an impact on Jupiter. So this is something that's that people have to watch. They have to, if they can, just Google Detect Jupiter, and they will be, they can download the software, and basically all they have to do is to run through the software after the imaging run through Detect to see if there's an impact.
Yeah, NASA credits you with co-discovering the first impact back in 2010 with twice discovering outbreaks related to the southern equatorial belt, I believe, right?
Yeah. Well, we've understood the fade and the recovery cycle of the south equatorial belt, because if you notice, these belts would turn white sometimes. It's not just the SEB but also the NEB, and we found out that the reason why, in fact, this was one of the papers I posted in one of the DPS meetings, I think over 15 years ago, was that these outbreaks, which quite surprisingly starts with a dark barge in the SAB, a dark cyclonic barge. Suddenly an eruption would start, and from this eruption, the belt would revive from pure white to what it is normally, a red belt. And the same thing happens with the NEB, the STB, and the NTB. In fact, the NTB, twice we had a paper in, was it Nature, where the same thing happened. There was an outbreak that occurred on these belts, a very powerful outbreak, and basically it revives the belt. So this is something that amateurs discovered, and from frequent revivals and fade cycles with our data, we were able to basically find out that this cyclical event is basically what keeps these outbreaks. And most of these outbreaks, if you notice, happen in the area where you have the wake of the great red spot.
Mm-hmm.
You notice that many times in this wake, you have violent outbreaks. And in fact, during the time when the SEB fades, the outbreak, the wake of the great red spot disappears. So this has been something that we were able to basically using, with the amateur data and with the help of professionals, we were able to understand this thing that it's this, that violent wake that follows the great red spot and the outbreak on this wake that keeps the SEB red.
Mm.
So this is something that's quite interesting for us to learn in the last few years, and of course with the contribution of the amateur astronomers on this.
That's what I love about planetary observing. It's so dynamic. It's always different. So walk us through a typical imaging night from your setup to final image. What do you do?
So basically, I have my telescope set up outside and just cover a tarp. So the first thing I do, especially when I'm
You don't have no
right
big expensive dome covering your telescope?
The problem is that having a dome and a small observatory is not recommended here because we get powerful typhoons. I mean,
yes.
The last one we had was about almost 140 miles per hour.
Oh.
So it was pretty bad. We didn't have electricity for a month here. So we can get violent storms. And I had a friend who had an observatory here, and during the last storm, it was just wiped out. So I don't want to have that. So I just have a temporary thing on my veranda, and I just cover it with tarp. And I just make sure that I take out the tarp, especially when I'm imaging early in the evening, to take it out and have my OTA cool. It takes a few hours to do that, but it helps in getting good image. I think one big problem with a lot of people is that if they start imaging without cooling their OTA, it's going to be a big problem.
Mm-hmm.
In fact, if I don't cool my OTA, it's not worth imaging. It's just that.
True.
So from there, I get things ready, cool my OTA, then I take my image. So whether it's 4 o'clock in the morning or 2 a.m. or 8 a.m., I go through the same routine. It's just basically a basic workflow that I do. Of course, having the AP900 helps a lot, having a stable mount, and it's already polar aligned, so I can go directly to Jupiter.
Okay.
With my telescope basically already focused. So, and also I also use a flip mirror because it's very difficult to get the planet in the chip. And also I right now, that's the reason why I also use a big chip. I use a 585 Sony IMX 585 from QHY, a big chip, so that I can get the planets in the center immediately and just use ROI. And after taking an image, I normally take a color image, whether using a color cam or RGB. Then I take a methane band image, an IR or UV if the seeing is good. Then another color image. Then that's it. Especially early in the morning, it takes me about half an hour to go through this sequence. In the meantime, because I use a workstation laptop, I try to process some image to make sure that the focus is correct. Because sometimes when it's early in the morning, your brain isn't really 100%. So you make sure that the image you got is sharp and everything. And if there's a slight problem with focus, I try to adjust it a little more. But most of the time, I basically nail the focus anyway. Okay, I don't use any method for focusing. I use a method called jogging. So I just get in and out of focus.
Okay.
There's really no trick on this because a lot of people ask me, is there an autofocus on this thing? Unfortunately, there's none. You just have to use your eyes, and it's easier. For example, for when I'm image Saturn, I just use the Cassini division. I just look at it and make it as sharp as possible.
There you go.
For Jupiter, I just go to one of the moons, and it's easier having a distinct moon. and I just get the best. It's easier when the seeing is good, but when the seeing is bad, I do a process called jogging. So I just go in and out focus, and
that makes sense.
I get the median.
Yeah. So what software is in your workflow?
So for capture, I just use Fire Capture. That's it.
Wow.
And for processing, I use AutoStacker. For post-processing,
those are all free softwares too.
Yeah, those are all free softwares. And the reason why, I know some people use SharpCap, but the thing is, with the problem with SharpCap, most of the controls are not accessible immediately. Fire Capture is really built for planetary imaging. Although it's a bit quirky, I have to admit. I mean, sometimes things go crazy because number one, it's a Java software. And what I have to do is I have to basically uninstall it and get a fresh install just to get it back working. It's quirky, but it works. It controls my mount. It can center my image automatically by controlling my mount. It can control my focuser and my basically my filter wheel. So everything is there in the software. So everything. Right now, one thing which an accessory that I got is Prima Luce Isato. One thing nice about this is that when it's a Crayford focuser, and it's controlled by Fire Capture. And one thing amazing is that, especially when you're imaging RGB, even when Jupiter is overhead, it seems like because of my Schmidt-Cassegrain, the focus of the RG and B is not the same. It's never the same.
Wow.
So one thing nice about Fire Capture and Isato is that I can fix the focus, and whenever it changes the focus for each filter, you just go back to the focus. It remembers the focus, and this has helped me improve my image of Jupiter.
Because they're consistent every time you change.
Consistent, and before I had this focuser, what I had to do was focus on green and live with unfocused blue. You don't have time to refocus because in my workflow, because right now what we do is we derotate the image, and because of using derotation, and also derotation helps a lot in improving the image quality and overcoming two problems if you have poor transparency and sometimes poor seeing by capturing more data. So with derotation, you're able to basically stack, it's basically what I call stacking on steroids. So stacking, compensating on the rotation of the planet. So with WinDupos, you can do that, or with a new software right now, which is much easier to use than WinDupos, Lucky Stack Worker 7. Which Wilco made, and basically it's an amazing software. For me, this is a game changer.
We've highlighted Lucky Stack Worker on this podcast. Yeah, it's amazing piece of software for that. So what mistakes do beginning planetary imagers most often make, do you think?
Well, it's not really a mistake because one thing I would, one of the first questions, one thing I have to tell planetary imagers is that, the best way to learn is just to do it. And, from there, you learn from your mistakes. Everything becomes second nature. Example, one of the things people always ask me is, what settings do I use? And this is a question which is very difficult to answer because I can tell you my settings, but it's not going to help you. Because it's just like saying that, you drive a car and what gear should I use?
True.
I mean, in any day, my setting is different depending on my transparency, seeing, the telescope I use, the object I'm trying to image. All these things, will have different settings. So from your experience, when you image, you will learn, you'll have the feel. It's just like cooking, some people cook, they have to go through the recipe, everything, with the exact detail.
Right.
But in planetary imaging, it's like cooking, but with a feeling. you feel. I mean, one thing that I do is I also cook. I understand that how much salt you place. Well, it
Yes.
depends. I mean, or how much of this. After cooking some time, you get the feel on how to do it. The same thing is with planetary imaging, like using a skate. The first time you skate, of course, you fall off many times. But once you get the feel of it, you get the hang of it.
There you
You
go.
understand. And for me, it's not about mistakes. We all make mistakes. We learn from them, and we learn from them. And many times, what might be good for me might be bad for you, might be a mistake for you. So from here we learn,
Right.
and we get better and better. But even now, I would say, do I know everything? No, I don't. Sometimes I talk to people; they have their own method, and sometimes I find their methods better than mine. So in our case, even though I've imaged for more than 25 years, I still learn. We still learn, even from beginners.
Right.
Sometimes they see things that we do not see. And the same is true with planetary imaging. And for me, my best suggestion is don't be afraid of mistakes. You learn from your mistakes, and from your experience, say, I will not do that anymore. But sometimes a mistake could be useful sometime in the future. You do it and it worked.
Yeah, true.
So you never know. So it's good to have an open mind to listen to what people do. There's no such thing as everything is fixed. You keep on learning. Example, when Lucky Stack Worker came out, I mean, at first I was hesitant to use it, but when I found out that it's so easy, the first thing I can see is that a lot of people are intimidated with WinJupos, that image measuring thing, these things. And with Lucky Stack Worker, everything is automatic. I mean, everything is easy, and I'm happy for it. It's not like I want everything to be secret and I want to be the only one to make good images. That's not what I want. I want everybody to have images like mine, so I won't have the pressure of imaging every night, especially at my age right now. That I can't do anything anymore.
It's all on you, Christopher. It's all on you to keep it going. Yeah, you're the perfect example of the serious scientific value of amateur observing. What makes amateur observing useful for professionals?
Well, basically, because we can do data every night. And as I said earlier, they cannot get data. I mean, it's very difficult to get telescope time, professional telescope time. In fact, what's happening right now is we do the discoveries, and when there's a discovery, they have a reason now to use the Hubble Space Telescope or the James Webb, Keck, VLT. They have a reason. There's this big event happening, so we can get telescope time now. They cannot just, we're gonna get telescope time and hoping, something might happen today or tomorrow. No, that's not gonna happen. So it's the amateurs that are leading the way now, with all our data. We are the ones being able to see what's happening with the network that we have all over the world, and this thing helps a lot. And that's why we're very useful. We basically it blurs the distinction between amateur and professionals. Well, the only difference between amateur and professional is in professionals you get paid for it.
This is true. So
or probably you get a PhD, and because like E. Bernard, he never got a PhD.
That's right. Well, you take these fantastic, scientifically accurate images, but along with that image, you need data.
Yeah.
So what data should observers submit when submitting their images?
No, what they need is just the time, date and time, their location. That's it. And of course, the CM numbers.
Right.
The CM numbers is more important for other imagers, so that when they see the image, they know where to get the follow-up image. So basically, that's the important thing. The time has to be very accurate. That's why it's a good thing right now the laptops are basically synced with atomic time. But in case, just in case, I would recommend you download a software called TARDIS. It's a very old software, or you can use the one in Windows. I'm not sure with Mac because I don't use a Mac. You can sync your time before you take an image, and from there, it's not really a problem. And the only thing I would like to ask is when you capture data, and it's in fire capture, make sure that you use the WinDuPost file naming convention.
Yes.
The WinDuPost. So you have an actual timestamp, because one thing nice about fire capture, it uses the mid time automatically. It saves on the mid time. Let's say you have a 30-second capture, it will save on the mid time. And when you use WinDuPost to derotate or Lucky Stack Worker, you know where the mid time is. So there's no more guesswork. And with the WinDuPost file naming convention, it's basically automatic. To you don't have to enter the date or time. Just the WinDuPost would pick it up. So these are the important things that you need to do when you're capturing data.
Yeah. Christopher, this has been a wonderful conversation. Your work is a reminder that amateur astronomy is not just about looking up, it's about contributing, documenting, and sometimes seeing something before anybody else does. For our viewers, your story is exactly what the Association of Lunar and Planetary Observers is all about. Careful observing, patience, and a belief that amateurs can still make meaningful contributions to planetary science. I want to thank you for coming on the podcast today, Christopher.
Thank you too. It's great to be able to talk to people about this, because we need more imagers.
Yes, we do. Accurate imagers.
Yeah.
Thank you very much.
Thank you.
All right, that's going to wrap it up for this episode of the Observer's Notebook podcast. A special thank you to Christopher Go for coming on the podcast today and talk about his amazing career as an astrophotographer. If you enjoyed this podcast, please take a moment to give it a thumbs up and subscribe and share the podcast with our listeners. New episodes of the Observer's Notebook are released on the 1st and 15th of every month. You can find us on iTunes, Spotify, and the ALPO YouTube channel. If you'd like to help support the podcast, you can do so through Patreon for as little as a few dollars a month. Up to $35 a month, we receive exclusive benefits, including a 1-year membership to the ALPO. You can find out more on our ALPO Patreon page and our ALPO website. Special thank you, as always, to Steve Siedentop and Michael Moyer for the continued support of the Observer's Notebook. And you can reach me directly by going to my email at tim.robertson@alpo-astronomy.org. That's all for now. Clear and steady skies. You can join the Association of Lunar and Planetary Observers today. It's just this easy. You can become a valuable member of this International Lunar and Planetary Astronomy Organization, founded in 1947 by Walter H. Haas. It's based upon the structure of the British Astronomical Association. You can join various lunar and planetary observing sections, contribute to our massive archive of observations. You'll have access to our extensive lunar and planetary gallery of over 20,000 photos and observations of the sun, the moon, comets, meteors, and the planets. You'll receive our quarterly publication, the Journal of the Association of Lunar and Planetary Observers. You have the ability to join the ALPO training program, which will teach you the finer points of making planetary observations. You can attend our annual virtual conference, and you'll have access to the Observer's Notebook podcast. Membership begins at only $22 a year. The way to find us, just go to your Google and type in ALPO Astronomy, and you'll see this prompt come up. There's our association with our website, alpo-astronomy.org, and you'll come to our homepage. If you look at the top of the homepage, it says Join ALPO. Click on that, and you'll come to the sign up screen. Gives you the information on the organization, and there's two ways to join. You can join by mail, where you'll download a membership form, or you can pay online using PayPal. This is the PayPal processing page. You just fill out a few information lines, and then you're given the chance to click PayPal and join the association. Welcome to the ALPO.